Okay, so here's the B-6 video. So the directions, which of the following limits can be evaluated by direct substitution? Evaluate those limits. So direct substitution is the method that we always want to try first when we're evaluating a limit. So because what direct substitution says, guys, it's like, think of the third condition of continuity. If the function is continuous at the value that x is approaching, then you've got the limit as x approaches a certain value of f of x actually equals the function value itself. So yeah, so this is based off of the third condition of continuity. So this first one, guys, when you've got a fraction like this and you're doing the limit, to know whether you can direct substitute or not, focus on the denominator. If I plug 4 into the denominator, does it make it 0? Because pretty much the only case, or the case we're going to see mostly when you can't direct substitute, is when the denominator becomes 0 if you do direct substitute. So if you plug 4 into here, you get 4 minus 1, that's -1. That's fine. So I'm going to do the direct substitution. So I'm going to plug 4 in where the x's were. Notice I don't have a limit here anymore. And then this is 11 over -1. That's -11. Okay, now what about B? Okay, so yeah, this one, all right, so this one, that one can be evaluated. Can this one be evaluated by direct substitution? So direct substitution would mean you're plugging 5 in where the x's are. But look, if you do that in the denominator, you would get 5 minus 5. And so you'd get 0 in the denominator. So that would be undefined. So that doesn't work. So you can't do it there. Okay, won't work. Okay, maybe I'll go like this. I'll go aside. Aside, we'd end up, so 5 plus 7 over 5 minus 5 equals, what is that? That's 12 over 0. Can't direct sub. Okay, because of this here. All right, now let's try this one. And like I said, let me do an aside, guys, just for our notes. But when you're on your own, just in your head, recognizing whether or not direct substitution would make the denominator 0, that's enough. But let me do these aside things for our notes. So I'll try direct substitution. So in the top, I'd get, so we get 4 over -2 plus 2, -2 minus 5. This is -8 over 0 times -7. That's -8 over 0. Okay, so can't direct substitute. And when I'm just testing, guys, to see if I can direct substitute, I'm not doing it like in the problem. I'm doing it as an aside, because if it's not going to work, I don't want like a mess over here that I just like have to cross out or to have to write the problem over again. Alrighty, so this one, if I plug 0 in, is that going to give me 0 in the denominator? No, it would give me 0 plus 2 is 2, 0 minus 5 is -5, 2 times -5, that's -10. So direct substitution is going to work here. So, and then this is 0 plus 2, 0 minus 5. So this is 0 over, no, that's +2. 0 over +2. Okay, so it worked for this one. So it just worked for A and B. All right, guys, that's like most of it. Now on the back, sometimes you're gonna, when you're doing a limit, you're gonna have to direct substitute into a trig function. So I'm not gonna go through this, but here's all of our trig. Here's some trig review. So you could use this as reference if you come upon a trig function and you're stuck. Okay, I'll talk to you later.